Thank you. That would be great. Yes, I'm ready. Yeah.
This is Sector Ability. Can you hear me?
I can hear you.
Thank you very much.
Hello, nice to meet you, Dr. Sabur.
Nice to meet you.
We are here at Polytechnical University of Victoria, and we want to thank you for the conference. And let me read your resume. Dr. Sabur holds a PhD and a master's degree in computer science from the Instituto Politécnico Nacional under the direction of Dr. Grigory Sidorov, and the bachelor degree of computer science from the Forman Christian College in Pakistan. His expertise lies in the field of natural language processing, with broad research interests spanning areas such as personality and emotion detection, low resource languages, and questions answering. He is dedicated to leveraging machine and deep learning techniques to develop computing solutions that offer deep insights into human behavior. Currently, he's a teaching professor and postdoctoral researches at Tecnológico de Monterrey. His work focuses on applying artificial intelligence to education technology, including adaptive learning systems and personalized content generation. He has earned several academic grants and awards and scholarships, and he has deployed his leadership in the organization of many different academic events. He also has published his research work in more than 30 journals, book chapters, and conferences. Okay. In this talk, we will explore how to build structured and multi-step artificial intelligence agents using LangGraph and advanced frameworks built on top of LangChain. LangGraph introduces a graph-based approach to agent workflows, enabling dynamic, flexible, and scalable artificial intelligence systems. We will start with an introduction to artificial intelligence agents and their application, followed by an overview of LangGraph differs from the traditional pipeline-based approach. Okay, Dr. Sabur, you can start your presentation. Thank you.
Thank you very much. Before starting, I would like to thank all the doctors for the lovely introduction. I'd like to thank the university for inviting me, and to all the participants who are attending the seminar. Thank you very much for attending this seminar. And before I start, can you please confirm if you can see my screen? If it's visible to all of you, I'm sharing my screen. If you can just confirm that, if my screen is visible, I can start.
For screen, that we are going to maximize the size of the screen.
Yes, perfect. Okay. So this seminar is about building agents with LangGraph. And LangGraph is one of the architectures, is one of the libraries that is being used to develop agents. And really, it has grown over the year or 2 years a lot. And currently, right now in the industry, most of the people are using LangGraph in order to create multi-agentic systems. And the purpose of this seminar is basically to introduce you to the concept of agents, how to build these agents, and basically teach you how to develop these agents using LangGraph. So what is an agent, first of all? An agent is a system that leverages AI models to interact with its environment in order to achieve a user-defined objective. It combines reasoning, planning, execution of actions to fulfill your tasks. So most of you guys must have interacted with ChatGPT. ChatGPT is basically an agent that is designed to interact in a conversational setting. So if you connect a large language model, for example, one of the OpenAI models, and connect it with your surrounding environment and give it enough leverage to take action based on the situation that is presented in front of it, that would be an agent. And an agent has memory. What do we mean by memory? Memory is basically an ability to record the past conversation or past context of whatever has been happening in that situation. Then we will have toolboxes connected to large language model that allows them to take an action. For example, a tool can be a search engine that is connected to large language model, which would allow the large language model to access that search engine, go over there, write anything based on the query, retrieve that, and use that context taken from the search engine in order to make decision making in your environment. Then the agents also have retrieval modules. By retrieval module, we mean any information that is stored in your databases anywhere. It can be a university database for a university agent that you're building, and you should be able to retrieve that information using that framework, and then the ability to reason in order to make decision making. All of these things, when combined together with a clear user-defined objective, basically makes a large language model agent. And the library that we are going to focus on to make these agents is basically LangChain. LangChain was the first library that was introduced that connected all the dots together. So that library had retrieval modules, that library had indexes, as we are going to see later on. And using this library, you were able to connect OpenAI, you were able to connect Gemini, or whatever large language model perhaps that you want to use. It is also possible to use more than one large language model, for instance. For example, you decide that for one layer of process, perhaps OpenAI's model is the best model to use, so you can do that. And for the next layer, you might feel like Gemini does the job perfectly well, and it's also cheaper, so you can connect the dots together, you can manipulate the situation, and you have a lot of freedom to choose from using these frameworks. And that is why rather than using something that is dedicatedly OpenAI or OpenAI library or dedicatedly Gemini framework or any other large language model framework, we use LangChain so that we can connect all of these things together and make our own foundational blocks. So LangChain is a framework for developing applications, which is agentic, which means that it allows language models to interact with the environment. And it is data aware, which means that you can connect your personal sources of data. So these are all the components that LangChain allows us to use, starting with models. So you can combine OpenAI, Cohere, or maybe any one of the Hugging Face models that are not large language models, perhaps transformer-based models that you can concatenate and use. Then it has several layers for several types of functionalities that can concatenate with these large language models. You can define if you want to have a chat-based models, which is not a zero-shot prompt input and output, but rather you want to design it in a chat sort of interface. And you can also have access to various text embeddings in order to convert your text into vector representations, or perhaps you want to use your images and convert them into vector representations. These models are available in LangChain for you to use. Then you have indexes. In indexes, you have several types of features. For example, you have document loaders. And if we talk about document loaders, it can be your Google Drive, it can be Azure database that you want to access. So it can be any format of document, can be a PDF, can be an image. So these document loader functions basically allow you to load your documents and then also perform various natural language processing functionalities. For example, splitting the text into smaller chunks, or you can use some layers in order to summarize them, pre-process them. And it also allows you to use vector stores. So vector stores take your documents in any format, convert them into embeddings using the text embedding models that are available in LangChain. Once you have those embeddings, you store that information in some vector store. If I zoom out and go directly into the documentation of LangChain, over here, you're going to see, first of all, retrievers. So these are all the retrievers that you can build, that you can use. You have retrievers related to Amazon, Azure. You can have an archive retriever. And these things keep on adding. So you have over here Zapier, Dockeray, literally tons of retrievers where you can retrieve information from. You can have Wikipedia. And because LangChain is community-based framework, these things keep on adding. You can develop your own retriever and you can add it into LangChain. All of that is possible. And that's how we got here very quickly within the past 1-2 years of the development of LangChain. So you also have vector stores. So you can use Facebook's vector store, for example. Files is very popular. You can choose based on the properties of these vector stores. You can use ChromaDB. You can use MongoDB. You can use basically any of these. Perhaps you want to use an SQL server to connect your vector store for making your application. You can do all of that by basically using LangChain. So if I go over here in click files, you'll get all the code basically that you need in order to develop this application. Now, I'd like to point out the reason why I'm showing you the documentations directly from LangChain is because a lot of people now are using coding agents, or they're using code-based large language models in order to generate code. These libraries get updated very frequently, and hence, if you're going to just go and ask ChatGPT to write you the code for it, most probably you won't get the right code because these libraries are being updated very frequently, and the syntax changes very frequently. So you should be able to read the document, go into that library, select the module that you want to integrate in your application, and be able to do that because you have all the documentation and code written down in front of you, right? So then again, if you go, you'd see that you also have access to various agents. So over here, you have access to several tools. And tools are basically functions. You can create your own tools, or you can have access to already pre-made tools that are available on LangChain that would conduct a function for you on your behalf. Now, that tool can be as simple as a calculator. So instead of writing a calculator function on Python, you can just call this tool, give it an input, and it will give you an output, right? And then you have various forms of large language model based agents, React based agents, conversational based agents that are available in LangChain for you to use. And then in the end, the most important concept that basically builds LangChain together. Initially, this concept was not available directly on the dedicated large language model websites, but LangChain was the first one to introduce it, and that was the concept of chaining different prompts together. So simple chains basically take in a prompt template, format it with the user input, and return the response to another large language model prompt that perhaps you want to chain together in order to get the output. If you develop an intuition or want to develop an intuition to understand that, a chain basically is a large language model output that is passed on to another large language model as an input. And these prompts or these different inputs and outputs are connected to each other in the form of a chain. So in LangChain, you can have access to pre-made chains for different purposes, or you can create your own chain. It's a very simple concept. Just input, use large language model API to have an output, and that output will pass on to another large language model prompt as an input, and then will give you an output. Right? In a very sequential format, you can concatenate 50 chains, 60 chains, 100 chains together in order to come up based on the complexity of your task. And the reason why you don't do everything in a single setup or in a single prompt is because you want to reuse those prompts and setups again and again in different scenarios, and you don't want to overcomplicate or hallucinate the large language models, and hence has to be very functional, very divided between different steps. LangChain also provides you a router chain. So this is again a very important concept. A router it is basically a chain that decides which direction to take. So in a graph-based setup, a router would be, let's say you have several subjects to choose from. Based on the input, the router would decide whether, based on the input, you should take the chain that is related to mathematics, or perhaps the chain that is related to history, or chain that is related to English. A router is basically the decision-making module that helps you decide which path to take. And so moving on to LangGraph, basically, LangGraph is a sister framework that is built upon LangChain. It's a framework developed by LangChain to manage the control flow of application that integrate in large language model. Development of large language model, LangGraph was basically inevitable because it allowed you to convert that sequential chaining into now a graph-based setup for graph-based solutions. We have been using graph-based solutions for several different type of problems in artificial intelligence, let's say for classification, for clustering, this and that. But for large language model, a framework was needed for that. And what does it give? So it is basically help. If you want to choose between whether you want to develop an application or an agent based on LangChain compared to LangGraph, the question basically comes down to freedom versus control. What do you need? Because LangGraph provides you a lot of control over your inputs and outputs that are passed in your environment. And LangChain perhaps is more freedom oriented, gives your large language model more room to be creative and tackle unexpected problems because you don't want an exact output that you have to pass on to the next module in order to take decision making. And LangGraph gives you that type of a control, as we are going to see again in the practice as well. So which framework to choose basically depends on if you want to have multi-step reasoning process that needs explicit control on the flow, then that would be LangGraph, right? If you want to have applications requiring persistence of state between different steps, again, LangGraph. Or you want to have systems that combine deterministic logic with AI capabilities, or whether you want workflows that need human-in-the-loop interventions, or you want very complex agents architecture with multiple components working together, perhaps a multi-agent network that has several different agents that talk to each other, interact with each other, and then make the decision-making process. LangGraph is amazing in doing all of that. And that is why I decided to have a seminar that is specifically focused on LangGraph so that you are able to generate those type of agents. So in large language model applications, level of autonomy is also very important to understand in order to choose what type of framework you have to take. So in a very simple coding environment where you just have to code the entire system, all of the process is deterministic. You have to decide all the rules, you have to decide all the steps. So the output decision of the step is decided by you, the code that you have written. To decide which steps to take is also decided by the code, and to decide what steps are available to take is also decided by the code, right? And this is not something that we want because it's basically not autonomous. It's entirely deterministic. A large language model call, let's say a zero-shot prompt or a few-shot prompt, basically takes that first step away and gives you the output, which would be automatic, right? You don't have to decide the output. You just have to trust the reasoning capabilities of large language model, and hence the first step is taken care of by the large language model. But still, in the large language model call, after you have the output of that large language model, you still have to decide which steps to take. You still have to decide what steps are available to take, right? And that large language model call, which is just input and output in a chaining process, that becomes multiple steps. But in the end, you get a final output that you're desiring, and the same deterministic process follows. However, in the concept of router, you basically have an output, and then you can also decide the steps that are further needed to take. And then in the end, you would be taking the steps based on some rule-based systems that you have developed, right? But the difference between a router and a state machine that is very automated is that router does not have cycles. So it's just a one-time decision making, but state machine basically runs in cycles between the agents until you have a decision to take. And a fully autonomous agent would be the one that generates output, decides what steps to take, and then decides what steps are available to take, again in a loop, and that loop keeps on running. That is something that is what we look for while we develop these large language model agents. This is the final goal that we have to reach, right? In many of the situations, perhaps this is not the ideal solution that you're looking for. In many of the situations or solutions, you perhaps need a human in the loop. LangGraph also helps in that process a lot. So you can have a function that basically, whenever you reach that state, you stop over there, then a human being is involved in order for making a decision, and then you go on to the next steps. So LangChain basically is sequential. From node A, you'd have some step, you'll go to node B, you'll not C, go to node C until you have an output. LangGraph, on the other hand, is more graph-based solution, where you from node A, you can either go to node B or node C or node D, depends on the output of node A, right? So a lot of conditions are being talked about over here. So some important components that we have to discuss in order to understand LangGraph, and it is entirely based on this concept of state machines, or in the concept of states in LangGraph. So state represents all the information that flows through your application. So it doesn't matter if you're in node A, in node B, in node C, all the information that you always want to have a know-how of is going to be in the states. States are user-defined. States are user-maintained and passed between nodes and execution. And when deciding which node to target next, this is the current state that we are going to be looking at. So a pro tip for that would be, think carefully about what information your application needs to track between the steps, what information is extremely important for you in to always track between your entire agentic flow that you are going to create. So a very simple state function would be, it always uses type dictionary as a parameter. So you'd be importing typing library, and you'd import type dictionary, and you'd just define the class, let's say in this case, basic state. And in this basic state that we have, the information that we want to record would be the variable count, which is an integer. So it can be a count variable, it can be a number of turns, let's say in every conversation, it can be what information is being passed on from state to state, it can be anything, right? If you want to keep a track of some information in the entire workflow, that has to be defined in the state. A more complicated example for that would be, so again, you develop a function, a class over here, which is called complex state. And in this, you have two variables that you want to keep a track of. One is the count of the conversation, and then the second would be the list of human messages and AI messages that are basically being written across your application. If you're confused at this point, don't worry. We are going to practice all of that. We are going to see how it all works. So it's going to make sense in a few minutes. The second concept, like in every graph-based setup, is nodes, right? And nodes in these agents are basically Python functions. Each node would take the state as input. So every node that you are going to define will take the state as input, because we want to track the information in every node. Will perform some operation, whatever function you want that node to perform, and will return update of that state so that we can pass that info, or we have the updated information of that state in the next node. Nodes can contain large language model calls. The text that is generated during the decision-making process. It can have the tools. For example, a calculator, could be a search engine, could be anything, any tool that you want to interact with. These nodes can be conditional logics that can determine what step to take. In case of a router, that node would be a conditional logic type of a function. And it can also be a human intervention. For example, if you want a function, um, um, you want to design a function where a human input is required, you would develop a function with human intervention, and that can be your node. So it can be anything. Large language model call could be a tool to for some tool specific function, could be a conditional logic, could be a human intervention, right? And you can also develop state modification functions over here in every process, in every node, which, for example, if we have a state which is increment basic state, so we would develop another function to increment a counter in the basic state, which would just take the basic state, would add 1 every time in it. Or you can make perhaps a more complex version of that by adding new messages in the state every time. So in that case, the function would be add message. So in every node, you would be adding message to the state that already exists. So it's like you're updating information at every step. So another example for that would be, let's say you have a state right over here, and in that state you have a string which tells you about the graph state of certain thing. You would add nodes to it. These are basically functions. So whatever the graph state would be, any string, let's say I am over here, it would just additionally at every node add a substring to it. In this case, I am happy or I am sad or whatever. So whenever you reach at that point, it would add some part of the string to it in order to complete the sentence. Just a very basic example of that. And in the end, we have edges, right? Edges basically explain what direction to take between the nodes. If you are already familiar with graphs, you know that these can be directed graphs, conditional graphs, cyclic graphs, all of those graph related properties that you have learned in your career can be implemented using LangGraph. So edges define the possible transitions between steps. They connect nodes and they define possible paths through your graph. It can be a direct edge, for example, always from A to B, you can go between A to B directly, right? Or could be a conditional edge. So you have to choose based on something, whether you can transition from node A to B or perhaps from node A to C. So there are two types of edges that are available to us. So over here, if you see this example, you'd see that always we have an end state that we have to import in LangGraph, and that end state would basically tell us which perhaps node would you end your algorithm in. So what part would you end it to, and that would always be your end state. So your basic state or start state would be whatever state you have developed, and then you would increment nodes that would have functions, and then in the end you would have the last final edge that will take you towards the end, right? That is the basic. These are the basic steps that you have to take in order to develop any LangGraph based agent, right? So now let's do the fun part. The theory is over. Let's go and practice all the concepts that we have learned. So if you go, I have already given you this file. I've shared this PDF with everyone. So let's reconnect this. The first step would be for you to install LangGraph. Let's see if it's still running. Yes, of course. So I have created a basic state. The information that I want to track in that state is the string. I'm calling it graph state. And then node 1 basically concatenates I am, node 2 concatenates happy, node 3 concatenates sad. So either you can be happy or you can be sad, and that will be decided based on the conditional logic. So in the function that I've made, basically I'm saying that randomly decide whether you want to go to node 2 or whether you want to go to node 3, right? Just based on some random probability function. So it does that, and that function, this is where we are building the entire thing, right? So we have a start point. We have to indicate what would be the starting node when we have that, when we start our agent. In this case, would be node 1, which state says I am. And in that node, the state of this variable would be I am. Yes, Dr. Marco. Yeah.
Please continue, Sabur. Please continue.
Okay, sure. Right. Well, what happened? Right. Perfect. So over here,
Excuse
you
me,
see
Sabur.
that.
Increase the letter size, please.
Of course, sure.
Thanks.
Is it better now?
Okay, that's fine.
Okay, perfect. I think I can make it a little more, but yeah, okay. So over here, I'm basically adding all the nodes together. And from LangGraph library, you would define your state graph. You would put your state, whatever you have written over here. In this case, this is my state that I want to track. You would define your state. Then the first node would always indicate start, and the end node would always indicate the end, which is predefined functions in LangGraph. Over here, I'm defining all the nodes. So this is the name of my node. In this case, node 1 is the name of my node. And here I am defining the function of that node, right? So over here, if you see, this is node 1, the function that I created. And I'm going to add nodes. So node 1 is node 1 with node 1 functionality. Node 2 is with node 2 functionality. Node 3 is with node 3 functionality, right? And then I will develop edges. So once I have all the nodes and I know what information I want to track in these states, I will add edges. So the first edge that I want to have is a very simple edge. Okay, just go from start to node 1. Okay. Once you have done that, you will have a conditional edge from this node 1, and that will be based on your decide mood. So it can be anything, right? So randomly it will decide whether to go to node 2, randomly it will decide whether to go to node 3. And in both these nodes, whenever that node is reached, I would ask you to basically end the agent. So over here, our builder that we have defined is adding edges and defining the graph, and that's how our graph is basically completed. Once we have that, we are going to compile our builder, and we can also visualize it, right? Over here you can see that I'm visualizing it and converting it into an image, and you say that this is the start state which goes directly into node 1, and from node 1, based on some conditional logic, you're going to node 2 or node 3, and from there on you're going to end. A very, very simple LangGraph based agent is now completed, right? So whenever I invoke this thing, so probably I have to rerun the entire thing again. Right, so whenever I invoke this, it's either going to give me, well, let's just wait for it for running. Probably I have to restart the session again. And very quickly run the entire thing again. Yeah, so it will give you, hi, this is Lance. I'm happy or I'm sad every time. Every time I'm gonna run it, it's going to take the initial state, in this case, which would be, hi, this is Lance. And then it's going to concatenate in every node, something like I am, could be happy, could be sad. Every time I'm gonna run it, based on the probability, it's gonna show me happy or sad, right? So now let's create something more complicated out of it, right? In this case, I am going to develop an agent that has access to the environment, which is your email system, right? Perhaps your Gmail, your Outlook, whatever emailing system you want to use. I want to develop an agent that takes every incoming email that you have and then decide whether it's a ham or it's a spam. So in case if it's a spam, this agent, we are calling it Alfred. He opens the letter, reads the content, classifies it as spam or ham. If it's a spam, then I want the agent to throw away the spam and basically end the graph. And if it's a ham, then I want to craft a basically reply for that email, validate the entire message, and send it back to the user. This is what I want from the agent to do. So let's see how we can do that, right? So over here, I'm using different variants of type dictionaries. I'm using lists. I'm using dictionaries. I'm using any, which any is like you use any whenever you're not sure what type of information will show up, and you use optional whenever you're not sure if that information is going to show up in that particular email, perhaps, right? So in this case, we are not sure whether the email category would exist, so we are basically making everything optional. And then we are also recording the metadata. So the state, in the state that we are developing, we are calling it email state, and that email state is basically recording the email that is going to come, the email category, the spam reason, whether it is a spam or not, whether it has email draft, or whether it has any metadata information that we want to record. So in that email state, we are defining everything that we would like to have a record of. Once that is done, we are going to import our OpenAI key. I'm using OpenAI in order to as an LLM that I want to use. So I have my API keys over here just for demonstration. I'm going to import them. Then I have these following functions that I want to use. So I want one node to have a read email function that basically just reads and stores the information in a variable. Then I want a function that's called classify email that classifies the email into different categories. So over here, I have a prompt that says, you are Alfred the butler, and analyze this email, determine if it's a spam or legitimate. If it's a spam, then explain why is it a spam. If it's legitimate, then basically categorize it into inquiry, complaint, thank you, request information by taking it this following information. So every time from your email environment, it will take the sender, it will take the subject, it will take the body, and decide whether it's a spam or not, right? And then over here, we have to create a lot of checks in order to segregate, in order to extract that information out of that text and put them into their prospective categories. And in the return, we are going to basically return these variables, whether it's a spam, if it has any information related to the reasoning, email category, messages. And then how would you handle spam? Over here, you would just mark it as a spam, and then basically remove the email. And if in case if it's not a spam, then I want to have a function that basically writes a response to that email. So it takes the email, subject, body again, categorizes, uses the category that was basically declared over here in classify email. After it takes that, I want to develop a draft as a response to that. Draft a brief professional response that Mr. Huck can review and personalize before sending. So we don't want to directly send it to the user. We want to first get it reviewed by someone that is called Mr. Huck, so that he can see, oh, this response seems adequate, just send it. We pass it to large language model, we generate that, and then the last function would be to notify Mr. Hugs. So this is your response. Basically, the incoming email was a spam. I've deleted it. This incoming email was basically legitimate. And this is the draft that I've written. Do you want to modify it? Do you want to send it? And Mr. Hugs would say, yes, please send it. And all of that is being done in this function. And then we also need a routing function in this case to basically decide what direction to take. In this case, the routing email would determine the next step based on spam classification. If the state is spam, it will return spam. Otherwise, it will return legitimate. Now, once all of these functions are defined, we are going to put them all together into the graph format. And again, the first step would be to define your state. In this case, would be the email state that we have defined. Then we would use add node functionality to create our nodes. In this case, we have read email, classify email, handle spam, draft responses, notify Mr. Hug. All of those functions that we have developed are going to be added in the node. And then we are going to connect these nodes to different edges. So in this case, the start would be read email. That is always going to be the start. And then we are going to have an edge between read email and classify email. That is a direct edge. And then we'll define the conditional edges that are going to be whether if it's spam, you'd go to a different node. If it's legitimate, you'd go to a different node. In this case, if it's a spam, you'll go to handle spam. If it's legitimate, you'll go to draft responses. Right? And you would add these edges in the end. If it's a spam, handle spam, end it. If it's draft response, then draft response and notify it to Mr. Hug. And after notification to Mr. Hug, every time it would end this entire thing. So we run this. And then we are going to basically pass on this information. One would be a legitimate response, one would be a spam email, and let's see how it responses. So it will go through all of this and will give you two outputs. One would be processing legitimate email. It goes into the entire node and basically decides, takes steps. Sir, you received an email from John Smith. And I prepared a draft response for your review. This is the response. And would you like it to continue? And then you decide something. So obviously you can add human in the loop in this setup, add more modules to this spam detection agent. This is just a basic level code in order for you guys to understand how agents are developed. And then in the case of spam, you just identify it as spam. Alfred has marked this as spam. It does not have any reasoning at this point. And the email has been moved to the spam folder. And then you can also see the graph that you have built like this. So you have read email, classify email. From there on, you can either, if it's spam, you can go to handle spam. If it's legitimate, you go to these legitimate nodes. And in the end, you're going to end this particular thing. Right? A pro tip that I'd probably like to give you is always use structured outputs in order to in order to create responses, because large language model hallucinates a lot. Even although we are using temperature 0 over here, which would mean that every time it would have like a deterministic response, but always with varying inputs, you'd have varying outputs. There is a lot of hallucination. So in order to keep it more consistent, we use structured outputs in large language models now. In order to read more about it, you can just go to any library, let's say OpenAI, go to documentation, go to structured outputs over here. So I'm over here in platform.openai.com. In the documentation, I go to structured outputs, and you'd see that they always use Pydantic in order to create classes that would help you basically take your input, take your output, and transform it into a JSON structure. And you can pass your class that you have created directly in your API call, and that would give you a parsed output accordingly. And you can also define the description of these variables so that you every time you get a very consistent deterministic output. And concatenating that with LangGraph would help you a lot in your development journey. Now, the only question perhaps that I know, I think I'm a little over the time, and you would have some time for question answering, but I'll quickly wind it up. How would you use tools to concatenate over here, right? Very, very simple. Just go to this documentation. You have various tools over here. You'd see that you have plethora of tools that LangChain already provides you. This is not a complete list. I think there are more tools, or you can develop your own tool as well. Let's say you have an API, you can connect it, or you can just create some Python function that can be used as tools for decision making. Over here, I'm showing you one very quick demonstration. I'm using Tavily, which is a search engine. If you'd go over here, you'd say Tavily. Tavily basically is a search API that gives you around 50,000 free calls per month. And very handy, very easy to use. You just have to go to Tavily's website, create an API, and you're ready to go. Over here, I'm having this Tavily key. Just from LangChain Tavily, you're going to import Tavily search. You're going to set it up, and this is how, based on your query, it's going to respond. It's going to give you everything, the content, the URL from where it took the content, and then it's going to format it into whatever JSON output structure you have defined, and would give you that. So if you were wondering how would I know how to use that tool, just go over here, just click it, and you would have the entire documentation on how to use it. So very, very simple, nothing complicated in that. So then you can also basically use different forms of tools directly in your graph-based setup. Over here, I'm basically showing you how to do that using Python REPL, which is a very, very amazing tool for calculations. The idea is that large language models hallucinate a lot during mathematical calculations. So instead of just asking the large language model to reason and give you an output based on calculation, you ask the large language model to generate a code for that problem. And when you run that code in a compiler, you're going to get the exact output for complicated mathematical problems. And Python REPL helps us do that. So I generate basically a tool for Python REPL directly. I import it from LangChain utilities, and then I can convert it into a graph-based setup where I'd have, let's say, if I give it an input, 2 raised to the power 5, it would give me the answer 32, which in most large language models, it would perhaps hallucinate and would not give you the right answer. So for very, very complicated mathematical problems, you can write a Python code using this free interpreter that is available in LangChain and run it and get your answers. And then you can concatenate into your graph-based agentic setups. So very, very handy, very, very easy to set all of this up. Now I think the rest of the time I'd leave it for you guys to ask questions. If you want to find me, you can find me over here using the scanner. I'd leave you guys this tutorial, this Python notebook. You can find that in the slides if you want to access that. If now you have any questions, I'm happy to answer.
Thank you, Dr. Sabur, for your presentation. We are very glad to have that you have shared all your knowledge with us, and we are very happy at Ciudad Victoria, Tamaulipas, and listen to your presentation. Anyone have any questions for the Dr. Sabur? ¿Alguien tiene pregunta? ¿Alguna pregunta? Pues puede ser así, si quieren español, en inglés, si quieren en inglés directo. ¿A una pregunta ya puede pasar por acá? Yes, we have a question.
Amazing, right?
Hi, Dr. Sabur. My question is, what are the most common challenges when building an AI agent?
Well, the most, I think the challenging thing while deciding, while building an AI agent would be to see what's happening at every node at a certain point, because this is a very basic setup. But when you're going to develop something professional, you're going to perhaps have hundreds of nodes and hundreds of edges that are connecting those nodes. And whenever you run that, you'd want to see what is happening in the entire node. Where was that mistake which I could have improved? And for that, you use something that is called LangSmith. It's an additional framework that can be connected to LangGraph. You would always connect LangSmith with your agent so that you can keep a track of what is happening, where is it happening, what was the response. Let's say on node number 52, what was the response of the large language model and why did it mess up? And then the second thing, the most important thing, is evaluations. For every agentic setup, you would always create your evaluations. And evals is also supported by LangSmith. What are evals? These are real life situations that you would encounter when you're using your agents, and you would see whenever you're making any change how your agent is going to respond to those real life situations. So you're going to make a data set which is going to be your evaluation data set, and every time you have any agent, you would run it through your evals, and you would see the performance of that agent, and that would help you reduce a lot of mistakes and correct a lot of things before your agent is production ready.
Okay. Thank you very much.
You're welcome.
Dr. Sabur, we have one more question.
Sure.
What is something that you'd say that a beginner in the AI environment should know, and most of the beginners just don't do? For example, most AI models uses math, no, and then most of the engineers say you should learn algebra or something like that. What is something that you say most of the beginners pass of it, but it's very important?
Well, if you're beginning, let's say in artificial intelligence, these are baby steps that you have to take. You have to start from machine learning, develop intuition of how machine learning works or how a deep learning problem works. And by problem, I'd say that you have to understand what type of a problem can be handled by AI and what type of a problem is not an AI-based problem. That level of intuition is the most and foremost important thing in AI. There are several problems that you would encounter in your journey that can be done without AI, that can be done without machine learning, without large language models. And you have to have that sense developed. Whenever someone presents you a problem, you should be able to say, this problem can be done in a deterministic way or perhaps without AI in equally well fashion. So you don't have to spend money, develop resources using AI to do that. I think that's the most important thing. So you'd start with machine learning, deep learning, then you'd go to understanding large language models. So it's baby steps. I think it's not something that you can perhaps learn in a few days. So step by step, you'd increment and learn different concepts.
Okay, and what is something that you'd say to someone that wants to motivate someone that wants to learn machine learning?
Find a problem around you that is important to you, right? Every person has a problem. Every person has a problem that is close to his or her heart. Find your problem and then see if that problem can be solved using AI and machine learning. So I'm talking about machine learning solvable problems. Rather than just thinking about how am I going to learn machine learning, think about what is the problem that is closest to your heart and try to solve that problem using machine learning. So once you are motivated to solve the problem, you're going to learn everything that it takes to solve it.
Thank you very much.
You're welcome.
Thank you, Dr. Saur.
You're welcome. You're welcome.
¿Alguna pregunta que ya? Okay. We have no more questions, Dr. Saur. We want to thank you for your presentation. And we are showing, and we are going to give you a diploma, a recognition from the principal authority of the Dean of Universidad Politécnica de Victoria, that is Maestra Abril Alejandra Ramírez Erazo, and she thanks you for your presentation and your time and the knowledge that you have shared with us.
Thank you very much. Thank you very much again for inviting me. Thank you.
Thank you, Dr. Saur, for your presentation, and thank you for our students to be patient and attended this talk. This is the end of our ribbon. Thank you, everyone, for being here today. Thank you, Saur.
Thank you. Bye-bye.
Goodbye.
Bye-bye.
Ya,